So as a review, delta H is enthalpy and it's the heat flow. There is a typo on this slide. Positive delta H is endothermic, negative delta H is exothermic. So again, if you did not get that typo, make sure you fix that. Free energy is represented with G, and that's going to be Gibbs free energy. So our equation is Gibbs free energy is equal to the enthalpy minus the temperature in Kelvin times the entropy. Make sure you know this equation and you know it well. You'll see it quite often on the test. This is the be-all on if a reaction is going to be spontaneous. If free energy is negative, the reaction will be spontaneous. If it's positive, it will not be spontaneous in the direction written. So enthalpy and entropy contribute to the reaction being spontaneous. So again, delta G being negative is a spontaneous reaction. The two things that lead to delta G being negative or spontaneous is you want a negative delta H or an exothermic reaction, and you want an increase in entropy or a positive delta S. Those two things drive spontaneity. If you look at this equation, if delta H is negative and delta S is positive, that leads to delta G being negative, regardless of the temperature. A non-spontaneous process is when delta G is positive. So pushing the ball or the rock up the hill is non-spontaneous. It occurs, but only if you put energy into it. A spontaneous process is when delta G is negative. So once you make it to the top of the hill, then the ball is going to roll down the hill spontaneously. You no longer have to put energy into it. When a reaction's at equilibrium, delta G is 0. And finally, a non-existent process would be the ball chasing the person up the hill. That's not going to happen. So you need to write this chart down in your notes because you can have multiple choice questions that ask you at what temperature the reaction will be spontaneous if delta H is positive and delta S is negative, or any sign of those. Remember that positive delta S and a negative delta H are what drive spontaneity because a reaction wants more entropy and to be exothermic. So all temperatures, the reaction will be spontaneous. A reaction will not be spontaneous at any temperature when neither enthalpy or entropy are for spontaneity. So if it's endothermic and we have a decrease in spontaneity, it will not be spontaneous. When delta H is positive and delta S is positive, we want the delta S side to be the more important side. So we need it to be at a high temperature to overcome the endothermic delta H. And when delta H is negative and delta S is negative, then we want delta H to be the more important factor. So we need temperature to be low so delta S won't matter as much. So in this problem it says at what temperature is the process spontaneous? High and low are relative terms, and so to figure out at what temperature, you would need to set delta G at 0. Also, it says what's the normal boiling point? Well, whenever something is undergoing a phase change, it's at equilibrium. So when delta G is 0, that's going to be our boiling point. So they gave us our delta H, we plug that in. Notice the units are kilojoules per mole. We don't know the temperature, that's what we're looking for. And our delta S is in joules per Kelvin. You usually have to convert one of these. The most common unit for delta H is kilojoules per mole, and delta S is joules per Kelvin times mole. So I converted my delta S to kilojoules. And then solving for temperature, I get 333. That is the temperature when delta G equals 0, or when I have some liquid and gas are at equilibrium. So that's my boiling point. Next, you've got to look, and my delta H is positive and my delta S is positive, which means I need to have a high temp in order for it to be spontaneous. So at any temperature above 333, so there's our chart, positive, positive, high temp. So at any temperature above 333, the reaction should be spontaneous, because that would make my delta G negative. Go ahead and pause the video and try this one on your own. So if delta S is 0, then using our equation for free energy, we need to find out which reaction has the most negative delta G. The most negative delta G would be the most spontaneous. And if you look at the equation, if delta S is 0, then the T delta S, that whole section there will be 0, because anything multiplied by 0 is 0. So really, you can just look at the delta H. The more negative delta H, the more negative your delta G. So D must be the correct answer since it's the most negative delta H.